Good morning everyone. Today I am going to give the presentation on computer network subject unit 3. So coming to the topic, that is internet working. So unit 3 internet working. In previous video classes I have discussed about the network layer services, and in this we have discussed number of routing algorithms also. So this is the continuation topic of that unit 3, that is called internet working. So what is mean by internet working? So we have implicitly assumed there is a single homogeneous network. We have a single homogeneous network with each machine using the same protocol in each layer. So this assumption is widely optimistic. Many different network exists, including LANs, MANs, WANs. Numerous protocols are in widespread use in every layer. So in the following section we will take careful look at the issues that arises when two or more networks are connected to form a internet. So this is called the internet working. So now coming to the content which we have discussed in this internet working, that is how network differ, how networks can be connected, tunneling, internet work routing, packet fragmentations. So these are the different topics we are going to discuss in the internet working. So what is the first one? How network differs. So how network differs? So network can differ in many ways. The network can be differ in many ways. Some of the difference, such as different modulation techniques or frame formats, or in a physical and data link layers. These differences will not concern us here. Instead, in this following diagram, list some of the difference that can be occur in the network layer. It is preparing over these difference that makes internet working more difficult than operating within a single network. Okay, so this is called how network differs. So in this I having the list of following layers. That is a service. These are the items, and this is the some possibilities. So service offered. So what are the service offered by the network? Connectionless versus connection oriented. Connectionless versus connection oriented service will be offered. Addressing, different sizes of addressing, flat or hierarchical, and broadcasting, present or absent, also multicast, and packet size. Every network has its own maximum. So it means every network means we having the so many layers, network layers. So okay, now so every every layer we have the maintain the packet size, that is its own maximum size. Okay, ordering means what? Order or unordered delivery. Ordering means we are accessing whenever the sender or receiver, they will order the information whatever they need from their client. Okay, so order or unordered delivery. Okay, quality of service, whatever the communication is occurring, that should be quality without any absence, any occurrence of errors, so any problem, collisions. So this is the quality of service. Reliable communication should be there, that present or absent, many different kinds. Okay, so reliability, different levels of losses. So in the security, okay, privacy rules, encryption, etc. Security means whenever the communication is occurring between the two devices, so we have to provide security to avoid the hackers. Some of the hackers will be hack our data. In order to overcome that, we are providing some privacy rules and encryptions. Parameters, different timeouts, flow specifications, etc. Accounting, by connected time, packet, byte, or not all, not at all. So these are the different list of things considered in this network differentiation. Okay, So these are the some of many ways of network can be differ. So this is the different ways of networks will be changes. Okay, differences. These are the network differences also. So every mode it will be changes. Okay, so this is the list of this network. Okay, difference. Okay, and next when packets sent by the source, when packets sent by the source on one network must transmit one or more foreign networks before reaching the destination network, so which always may be different from the source network. So many problems can occur at the interface between the networks. So that is called the how network differ. So this is the first one. Next coming to second one, how networks can be connected. How networks can be connected. There are two basic choices for network different networks connecting different networks. There are two basic choices are there for connecting the different networks. So there we can build devices that translate and convert the packets from each kind of network into packets for each other network, or like good computer scientists we can try to solve the problem by adding a layer of indirection and building a common layer on the top of the different networks. So in either cases the devices are placed at the boundaries between networks. So this is the network can be connected. So this is the diagram here. This is the source and destination, and these are the routers. Okay, so having the this is the values we have given here. So this is the packet. I am translating the packets to the routers. The routers will be translated to the another router. The another router will be translated to the destination. So this like the packets will be moved between it. We having the virtual circuit. Okay. And this is the value of 802.11 IP address. Okay, and this is the IP address, and this is the Ethernet and IP address. So okay, these are the diagram. Okay, so this is called the network. So first diagram is the packet crossing different networks. So packet is crossing in the different networks. So second one is the network and link layer. This is the network and link layer. Okay, link layer protocol processing. So MPLC LS means multi protocol label switching. Multi protocol label. MPLS means multi protocol label switching. Okay, IP means internet protocol. Okay, this is the two diagrams which is having in the network that can be connected. So this is the second one. So what is the third one? Tunneling. So tunneling, handling the general case of making two different. It handles the two different networks. Internet network is extremely difficult. How there is a common special case that is manageable even for different network protocols. So in this case where the source and destination host are on the same type of network, but there is a different network in between. So for example, think an international bank with an IPv6 okay, internet protocol version 6 network in Paris, and IPv6 network in London, and connectivity between the office via IPv4 internet. This situation is having the figure here. This is the Paris. This is the Paris. This is the London. Okay. So here I am between the source Paris and London. Between that I am using the routers. Okay. So Paris to router I am using the IPv6 version. After this router to London I am using the IPv6 version. Between the two routers I am using one tunnel that is called IPv4. Okay, IPv4. So what is the this is the connectivity between the Paris and London. Okay, so the network which is used IPv4 between the two offices I am using the IPv4. Okay, so what is the use of this IPv4? This is in this tunneling a packet from Paris to London. So the solution to this problem is the technique called tunneling. To send the IP packet to the host in the London office, a host in the Paris office constructs the packet containing the IPv6 address in London and sends it to the multi-protocol router that connects the Paris IPv6 network to the IPv4 internet. So when this router gets the IPv6 packet, it encapsulates the packet with an IPv4 header addressed to the IPv4 side of the multi-protocol router that connects to the London IPv6 network. So that is, the router puts the IPv6 packet inside the IPv4 packet. When this wrapped packet arrives, the London router removes the original, the IPv6 packet, and sends its onward to the destination host. Okay, that is called London. So the path through the IPv4 internet can be seen as a big tunnel extending from one multi-protocol router to another. The IPv6 packet just travels from one end to the one end of the tunnel to the other. So it is a noise box. It does not have to worry about dealing with IPv4 at all. So neither do the host in the Paris or London. Only the multi-protocol routers have to understand both IPv4 and IPv6 packets. It affects the entire trip from one multi-protocol router to the other is like a hop over the single link. So analog may make tunneling clearer. So consider a person driving her car from Paris to, so this is the another tunneling. So this is the another example of this. So analog tunneling clearer. So consider a person is driving a car from Paris to London within a France. So within a France. The car moves under its own power, but when it hits the English Channel, it is loaded onto the high-speed train and transported to England through the Channel effectively. So the car is being carried as freight as depicted. Okay, so this is the diagram. In this diagram, at the far end, the car is let loose and on the English roads, and once again continues to move under its own power. Tunneling of packets through a foreign network works the same way. So in this this is called the tunneling. Okay. So next, coming to internet work routing. Routing through an internet possesses the same basic problem as routing within a single network, but with some added complications. To start the network may internally use different routing algorithms. For example, one network may use a link state routing and another distance vector routing. Since a link state algorithm needs to know the topology, but distance vector algorithm do not, this difference alone would make it unclear how to find the shortest path across the internet. So one operator may not want another operator to even know the details of the path in its network. So perhaps because the weights of the path may reflect the sensitive information such as monetary cost. So that represents the competitive business advantage. Finally, the internet may be much larger than any of the network that comprises it. It may be require routing algorithms that scale well by using a hierarchy, even if none of the individual networks need to use a hierarchy. So all these considerations lead to the two-level routing algorithms. Within each network, the intra-domain or interior gateway protocol is used for routing. So gateway is an older term for router. So it might be link state protocol of the kind we have already described. Across the network that make up the internet, the inter-domain or exterior gateway protocol is used. The network may be the network may be use different intra-domain protocols, but they must use the same intra-domain protocol in the internet. The inter-domain routing protocol is called BGP, Border Gateway Protocol. Okay, so this is called the internet work routing. Okay, next, packet fragmentation. So what is mean by packet fragmentation? Each packet or each network or link imposes some maximum size of its packet. So these limits have various causes among them. So packet size issues are hardware, that is size of the Ethernet frame. Okay, next, operating system. So that is all buffers are 512. All buffers are 512 bytes. Protocols, that is the number of bits in the packet length field. So compliance with compliance with some international standard. So desire to reduce error include retransmission to some level. Okay, and sixth one is desire to prevent one packet from occupying the channel too long. Okay, so these are the 6 issues, packet size issues are there in the packet fragmentation. So the result of all these factors is that the network designers are not free to choose any old maximum packet size they wish. Maximum payloads for some common technologies are 1500 bytes for Ethernet and 2272 bytes for 802.11 IP is more generous, allow for packets as big as 65,515 bytes. One solution is to make sure the problem does not occur in the first place. It done finding the maximum packet size will take through the network to the destination. This packet size called path maximum transmission unit. So this is difficult approach because the path may suddenly change, with which can unexpectedly changes the path maximum transmission unit. So the alternative solution to this problem, we allow the routers to break up the packet into fragments, sending each fragment as a separate network layer packet. There are two kinds of fragmentation techniques which are often used, namely transparent fragmentation and non-transparent fragmentation. So what is mean by transparent fragmentation? So okay, transparent fragmentation is nothing but that is transparent fragmentation, non-transparent fragmentation. First one is a transparent fragmentation. So in this approach, when an oversized packet arrives at G1, so this is the G1. Oversized means large number of packets will be arrives at the G1. The router breaks it into fragments. So this is the G1. So in this G1, if we get a large number of packet, so this G1 will be divided into number of packets, like small packets, okay, into fragments. Each fragment is like, these are the fragments, okay. This is the large packet. This packet is divided into number of small fragments. Each fragment is addressed the same exist router. So G2 where the pieces are recombined. So when the data is received at the G2 will be recombined all the data and become the one large size of packet. In this way, the passage through the small packet network is made transparent. So subsequent networks are not even aware that fragmentation has occurred, as shown in this diagram. So here in this this is the network, this is the first one. What is mean by non-transparent transparent fragmentation? The other fragmentation strategy is to refrain from recombining the fragments at any intermediate routers. Okay, any intermediate routers. Once the packet has been fragmented, each fragment is treated as through it where the original packet. The router passes the fragments as shown in this diagram. Reassembly is performed only at the destination host. Okay, so this is the packet. In this G1 I am divided into number of packets. After that After that at G2 also that information will be available. So the fragments are not reassembled. Here the fragments are not reassembled and until the final destination to reach the host. Okay, so this is the non-fragmentation. Okay, non-transparent fragmentation. And next coming to number of another example we having in this, the main advantages of non-transparent fragmentation is that require the routers to do less work. IP works this way. So for example, number of first elementary fragment in the packet. So this is the packet number 27. So after that end of the packet is 1. And this is the header, okay. This is the 0 is the first elementary fragment in this packet. So this is the end of the packet bit, okay. And in this having the A, B, C, D, E, F, G, H, I, J. So this is the byte, every size is the 1 byte, okay. So this is the header. So fragmentation when the elementary data size is 1 byte and the original packet containing 10 data bytes, okay. And okay, this is called the original packet containing with 10 data packets, okay. So next coming to this is the another, this is the header and this is also the header. Here we are having the 2700. This is the fragmentation when elementary data size is 1 byte and fragmentation after passing through the network with maximum packet size of 8 payload bytes plus header, okay. So this is the diagram of this. And next coming to this is the this is when while simple, this design has some attractive properties. Fragments can be placed in a buffer at the destination in the right place for reassembly. Even if they arrive out of the order, fragments can also be fragmented if they pass over a network with a yet smaller MTU. MTU means what we have seen now only, that is multiple protocol, multiple MTU means what maximum transmission unit, and so in this retransmission of the packets can be fragmented in different places. Finally, fragments can be arbitrary size down and to a single byte plus the packet header. In all cases, the destination simply uses the packet number and fragment offset to place the data in the right position, and the end of the packet to determine the packet flag to determine when it has the complete packet. So okay, na? So this is the another image of the fragments after passing through a size of 5 gates. Okay. So next network layer principles. So what is mean by network layer principles? So in this network layer principles, I have some introduction. So before getting into the specific, it worth taking a look at the principles that drives the design of past and made it success that it is today. So we will now consider to be 10 principles, that is make sure it works, keep it simple, make clear choices, exploit modularity, expect heterogeneity, avoid static options and parameters, look for good design, not perfect. So strict sending, tolerant receiving, think about scalability, consider performance and cost. So these are the 10 principles available in the network layer. Okay. So what is mean by network layer in the internet? Before going to explain this, we will individually discuss what is what is the mean of these 10 principles. Make sure it works means do not finalize the design or the standard until multiple prototypes have successfully communicated with each other. All designers first write the 1000-page standard, get it approved, then discover it is deeply flavored and does not work. Then they write version 1.1 of the standard. This is not a way to do. Okay. So this is called make sure it works. So keep it simple. When in doubt, use the simplest solution. William of Ockham stated these principles in the 14th century, but in modern terms, 5 features. If the features is not absolutely essential, leave it out, especially if the same effect can be achieved by combining other features. So this is called keep it simple. So make clear choices. If there are several ways for doing of doing the same thing, choose one. Having 2 or more ways to do the same thing is looking for trouble. Standards often have multiple options or modes or parameters because several powerful parties insist that their way is best. Designers should strongly resist this tendency. Just say no. Next one is exploit modularity. So this principle leads directly to the idea of the having protocol stacks. Each of the layer is independent of all other ones. In this way, if circumstances require one module or layer to be changed, the other one will not be affected. That is called fourth one. Next one is expect heterogeneity. So different types of hardware transmission facilities and applications will occur on any large network. To handle them, the network design must be simple, general and flexible. So this is called expect heterogeneity. Next, avoid static options and parameters. So if parameters are unavoidable, for example maximum packet size, it is best to have the sender and the receiver negotiate a value rather than defining fixed choices. So next, 7th one, look for good design. Now it need not to be perfect. Often the designer have a good design, but it cannot handle some wide special case. Rather than messing up the design, the designer should go with the good design and put the burden of working around it on the people with the strange requirements. So be strict when sending and tolerate when receiving. In other words, send only the packets that rigorously comply with the standards, but expect incoming packets that may not be fully conformate and try to deal with them. So 8th one is think about scalability. So if the system is handle billions of hosts and billions of users effectively, no centralized databases of any kind of tolerant and the load must be spread as evenly as possible over the available resources. Next one, consider performance and cost. If a network has poor performance or outrageous cost, nobody will use it. Okay, so these are the 10 principles available in the network layer. So okay, so let us know now leave the general principles and start looking the details of the internet network layers. So at the network layer, the internet can be viewed as a collection of subnetworks or autonomous systems that are interconnected. There is no real structure, but several major backbones exist. They are constructed from high bandwidth lines and fast routers. Attached to the backbones or regional, that is mid-level networks, and attached to these regional networks are the LANs at many universities, companies and internet services providers. This sketch has hierarchical organization is given below the diagram. So before going to explain the next collection of subnetworks in the network layer, so these topics are, so these are the network layer in the internet. So and IP version 4 protocol, IP address, IP version 6, internet control protocols, and interior gateway routing protocol, OSPF, BGP, the exterior gateway routing protocol, IGMP, internet group management protocol. So these are the different things available in the network layer in the internet. So this topic will be discussed in the next video class and these are the topics we are having in this IP address and IP version v6, and these are the explanation of these topics, and these explanations will be discussed in the next video class So and in this we are having These are the network layer in the internet. So these are the different topics, BGP, exterior gateway. These are the different things I explain in the next class. So thank you.